Okay guys, now that we've reviewed our circumference, we can get into arc length. So first of all, an arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. So let's go look at this down here and then we'll talk about what that actually means. So arc length, they're saying, is a portion of the circumference. So if you take a look at your picture over here, you've got circle P. Okay, we call it circle P because P is the center. And on circle P, do you see this little red part AB? That's arc AB. And that would be part of the circumference. And let's say the entire circumference or the entire distance around the circle is 15 feet. Well, then AB would be part of that 15 feet. So maybe AB is only like, I don't know, 6 feet or 3 feet or 2 feet or something like that. That would be the arc length of AB. So, definition of arc length. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. There are two formulas here that are given. The one we're going to use is we're going to use this bottom one. Okay, so first of all, arc length of AB. So up here at the top, MAB. This is the measure of arc AB in degrees. Okay, so every arc has a measure in degrees, and we'll talk about that more, but it's based off of its central angle, and we'll go over that. Now, you take the measure of the arc, you divide it by 360. Think in your head, why would we be using 360 here? And the answer to that is because an entire circle is 360 degrees. So we're only going to take the portion we want out of the entire circle of 360 degrees. Then we're going to multiply that by 2 pi r, which should look familiar to you right now because 2 pi r is the circumference of the circle. Okay, so whatever the degree measure is out of 360, and then take that, multiply it by the circumference of the whole circle, which gives you just the circumference of the little part that you want. And then last but not least, over here, the arc length of AB is measured in feet, inches, etc., because an arc length is an actual length. It's in inches, it's in feet, it's in something like that, versus on the other side where I had the measure of AB, and that's measured in degrees. Okay, so there's an arc measure and then there's an arc length, and they're two different things. So let's take a look at our first example and see if we can figure this out. So example 1, find the arc length of arc PQ. And then this little notation right there, that's telling you arc. Now, PQ is going to go from P to Q. And they want to know, okay, well, how long is that? Is that 10 yards, 11 yards, 12 yards, some yards? And we have to figure that out. So, arc length of arc PQ equals the measure of arc PQ. So do you guys see that little red outline that I did? And then do you see like the pie slice that opens up to him? This angle right here of 75 degrees, that's the arc measure. So we're going to take 75 degrees out of the entire circle, which is 360 degrees. Then we're going to multiply that by the circumference of the circle. Well, the circumference of the circle can either be 2 pi r or it can be pi d. So if we're looking at 2 pi r or we're looking at pi d, take a look at what you've got. You've got a 9. Well, is 9 the radius? or the diameter? And the answer to that is, well, it's the diameter, so I'm going to use that one. And we're going to substitute that in there. Pi, I'm going to use 3.14, and then d, which is my diameter, I'm going to fill in 9. At this point in time, we're going to take this and we're going to put it in our calculator. If you're using your phone, this is probably what I would do. I would take 75 divided by 360 and I would just hit enter. Okay, then I would hit times 3.14 times 9 and I would hit enter again. So the arc length of PQ is 5.8875, and if we round that to the nearest hundredth, I'm going to underline my 8, I'm going to go back to my 7. 7 is 5 or above, so I give it a shove, so 5.89, and we're talking yards here. So the distance from P to Q on your arc is roughly 5.89 yards. That's your arc length. Okay, let's try that again. Arc length of GH. Okay, so distance from G to H. First of all, I'm going to start with the measure of GH, and the arc measure of GH is my angle. So 75 degrees out of always 360, because you're taking it out of a circle, times your circumference. So 2 pi r or pi d. This time take a look at what you've got. Do you have your radius or do you have your diameter? You have your radius. I mean, you could quickly make it your diameter, but I'm going to go with that. So 2 times pi times radius, which we know is 5. Okay, once again, if you're using your phone, 75 divided by 360, hit enter, and then times 2 times 3.14 times 5, hit enter again. I'm getting 6.5416 repeating, so if I round that to the nearest hundredth, the 1 is going to leave the 4 alone, so 6.54 centimeters is the length of the arc between G and H. Okay, this time we need to find the circumference of circle N. Now if you remember, circumference means the whole way around the circle. Let's look at what we've got. So what we've got is, I know that this angle right here is 270 degrees. So the pi piece we're looking at is this whole thing. And I know that that green line right there is an arc measure of 61.26 meters. Well, that's most of the circumference, but the part of the circumference that's not included is right here. So I know my actual whole circumference is more than 61.26 meters. So if this is an arc length, I'm going to put 61.26 equal to the equation we've been using. Now, I know that that arc length of 61.26 corresponds with the arc measure of 270 degrees out of always 360 times the circumference. Okay, well typically when we're talking circumference, I'm giving you two options, 2 pi r or pi d. And then you look at your circle and you say, well, which one do I have? Do I have a radius or do I have a diameter? And the answer is, you don't have either, but you're trying to find the circumference. So I'm just going to write C, because it's always 270 over 360 times the circumference, and we usually put in one of those formulas, but we don't need it here because we just want the circumference. Okay, now we have to solve this thing. The way I'm going to do it is I'm first going to start and I'm going to multiply both sides by 360 because it's in the denominator. Okay, so this 360 is going to cancel that 360. So now I'm going to grab my calculator. 360 times 61.26 is 22053.6, and that is still equal to 270 times my circumference. Then I have to get my circumference by itself, so I'm going to divide by 270. Those are going to cancel out. So now I'm going to grab my calculator. I'm going to take 22,053.6 divided by 270, which gets me 81.68. I think we're dealing with meters, M, equals C, which is your circumference. That is what they wanted you to find. It is already rounded to the nearest hundredth, so there you go. We're all done. Next one, find the radius of circle G. So, once again, this time we need the radius, which is right there. We don't know the radius, but I do know the arc length, and that arc length corresponds to that arc measure of 150 degrees. So, arc length, 10.5 equals my arc measure out of 360 times my circumference. Well, this time we've got a couple different options. Do we want to put C there for circumference? Do we want to put 2 pi r there for circumference? Or do we want to put pi d there for circumference? Well, look at what you're trying to find. You're trying to find the radius. So probably I'm going to pick 2 pi r because that particular version has radius in it. Okay, now before we move on, I'm going to do a couple things. First thing I'm going to do 10.5 equals 150 divided by 360 times 2, and then instead of pi, I'm going to replace that with our 3.14 and then our radius. Next thing I'm going to do, same as before. I really don't like that 360 in the denominator, so I'm going to multiply both sides by 360. So the only thing that's going to happen here is that. Everything else is going to stay the same. On the left, we've got to take 360 times 10.5, which I'm getting 3,780 equals 150 times 2 times 3.14 times the radius. Now, depending on how you want to think about this, you can start dividing off, or I'm going to take all these things that are being multiplied together, and I'm going to multiply them together. So 150 times 2 times 3.14 is 942. Times r equals 3,780. I'm trying to find my radius, so I'm going to divide both sides by 942. Get rid of that. Take your 3,780 divided by 942, and I'm getting 4.012738, and then a whole bunch more decimals equals my radius. Round that to the nearest hundredth. So the 2 is lower than 5. It says to leave the 1 alone, so 4.01 equals our radius, and it looks like we're talking about feet here. So the radius of that circle is 4.01 feet.